Good evening. I have really good news. We are about to test our B-dot detumbling controller, which is based on the cross-product control using the rate gyros and magnetometers. This algorithm has first been tested inside MATLAB Simulink simulation. Then it has been ported into C programming language, and as our joint test system is totally wired up and can be moved, and so does also our flight model, we decided to put this controller inside an Arduino Uno. And this Arduino Uno has been also connected to a radio transmitter, the RFM22B, that sends then via a 70 centimeter airband the rate gyro data and the magnetometer data, and also the cross product and the actuation status of the magnotalker. Okay, so this test will be performed this Monday in the new year, the first Monday of the new year, in the Compass Lab at 15 o'clock, and I invite you to come in the lab and help us testing this controller. So, this is our setup. On that Arduino there is the B-dot controller running, and this is the transmitter, the RFM22B, that will send all the measured data and the controller data to a other Arduino, which in this case is our so-called ground station, and then we'll send the data to that computer so that we can have some readouts. Okay, so this is the battery. Then we power it up. Then we have up converter, that up and down converter that stabilizes the power of the battery to 5 volt and 500 milliamps. This is our IMU, so there are the gyros that are also implemented inside our compass satellite, and the magnetometers. Then here we have the visualization of the coils. So this is the X, this is the coil in the Y plane, and this is the coil in the Z plane, symbolized by some LEDs. And this row is the plus, and this row is the minus direction. Now, if I spin this satellite in one direction or another, these LEDs here will hopefully light up in order to show us the magnetotalker coils that would be activated in order to create the required torque control that would counteract against the magnetic moment created by this spinning and according to the geomagnetic field. So let's give it a try. So now I am spinning somehow in a X direction, and you see that the LEDs are flashing. So now this is a really dirty spinning. What we will do is we will place it on a turn disc for LPs, the ones that the disc jockeys use. I have a Technics 1210, which is really robust, and it should also be able to spin this somehow heavy setup, and this in a really clean and constant way, so that we would be able to really test one plane after another, and after that we will place it in some combined plane, And then we will compare this against MATLAB Simulink simulation and also perform some hand calculations in order to hopefully evaluate and analyze if this little guy here will do it right. You see also now when I stop the spinning, my rate is quasi zero, and then the controller stops actuating the coils. As long as I spin it, the coils are actuated, and if I stop, after a while it will shut down the coils. Yeah, so let's try. So this is it. As I said, this Monday at 15 o'clock in the Compass Lab, Ricardo and I, we will perform those tests, and we really invite you to join us to this test in the Compass Lab and provide us with some good advices. And until then, I wish you a really nice weekend and Happy New Year.